In this video, we'll be looking at modulus function. We'll be looking at what it is and what's the graphs looking like for modulus functions. Alright, the absolute value sign is these two vertical lines that will embrace any number. If you have a negative 5, the modulus function will make it positive. Modulus of any value will make the negatives positive and leave the positives as they are. So, this function has a modulus of 2x minus 3 and then 1 is added to it. What it means is that first we've been asked to calculate f of 5. Substituting 5 for x will give us 10 minus 3, which is 7. 7 plus 5 is simply 8. 7 plus 1 is 8. My bad. Okay, so what happens is that if we have a negative value inside the modulus, we will turn it into a positive value. If you have a negative 1 in this function here, 2 times negative 1 is minus 2. Minus 3 minus 2 will make it the minus 5. But the absolute value signs means that we're going to turn this negative 5 into positive 5. Therefore, the answer is 6. Okay, in this next part of the question, we'll be sketching some graphs. And in particular, you need to understand what's the difference between these two expressions. They look rather similar, but the modulus sign here is outside of the function. What it means is that first, in one part of the graph, we'll have positive of 2x plus minus 3. Okay, so, and we will at the same time, when the y value, when we get to if you think back to what we learned in year 12, graph transformations, every time some transformation happens outside of a function, that affects the output. Okay, outside of the bracket, affecting the output. What is the output? That is the y value. That means that the y value will flip to positive if it's negative, and if it's already positive, then that's fine. Where would the y value change sign? On the x-axis. Therefore, every time you see modulus sign outside of a function, the graph will be reflected in the x-axis, because all the negative y values will be turned into positive. So, let's pretend that we are going to draw the graph for 2x minus 3. Minus 3 would have an intercept of negative 3. Negative 3 is down here. So, at what point will it cross the x-axis? When we get, if we say y is 3 over 2, x is 3 over 2, that's the intersection point with the x-axis. So the graph would look something like so. It would have an intercept of minus 3, but it would bounce back up and actually have a V shape like so. Now, what is it? What is the y-intercept for this point here? Well, the y-intercept is the reflection of the intercept itself, which is 3. So the y-intercept is a plus 3. Okay, let me redraw my graph so that it will look better. Okay, the graph should be symmetrical. Symmetrical in this axis. Okay, my drawing isn't perfect, but you understand. You should understand. Okay, so what we have really drawn is the positive part of this graph. So we took 2x and minus 3, and when y was negative, we turned the sign around. That means that we put the minus sign in front of this graph. Okay, so when you multiply out the negative into this bracket, you get minus 2x plus 3. So this red part of the graph has this equation. Y is minus has a gradient. This part of the graph, the left part, has gradient minus 2x and intercept of 3. If I change the color here, this the purple box here represents this side of the graph. This is where y is 2x minus 3, but with an absolute sign, because the graph will never go below the x-axis. Alright, so I'm going to show you the graph of an x function on different x and y axes. If I change my pen color here, what this means is that when x is positive, we'll have a graph of 2x minus 3, and when x is negative, we'll have a graph of Alright, when x is negative, we will simply have minus 2x minus 3. Okay, so let's draw these two parts of the graph together. Again, the first part, the right side of the graph, will look as normal. The intercept is minus 3, so the graph will have a gradient of positive 2 and intercept of minus 3. But on the left side of the y-axis, we will actually plot y equals to negative 2x with minus 3. So the graph will be reflected in the y-axis in this case. Okay, so the takeaway is that there is a reflection reflected in y-axis. This graph is reflected in x-axis. Okay, so let's look at other examples. We've been asked to sketch the graph of modulus sign of 3x minus 2. Modulus sign is outside of the function, so the graph will have been reflected in the x-axis. We would have plotted a graph of y equals to 3x minus 2, and notice that the intercept is minus 2 and the x-intercept is 2 over 3. Right? So if you're not sure how we found this 2/3, you say y value is 0 when we have x-axis. So you said 3x minus 2 equal to 0, and you solve this. So you will have 3x equals to 2, and the x would be 2/3. That's how we find the x-intercept. Now, we have to reflect the graph in the x-axis. That means this side of the graph will flip up. The intercept was minus 2, but now it's plus 2. If you're wondering what's the gradient of this line, that is y equals to negative times 3x minus 2. You multiply out the bracket with the negative, and you'll have negative 3x plus 2. That's the equation of the left side of this graph. Notice it's perfectly symmetrical around x equals to 2 over 3. Let's look at the next question. We have to solve this equation. Solving this equation means that we are basically finding the intersection of the v shape with line of y equals to 5. So plotting 2x minus 1 in a modulus sign involves calculating this and finding the intersection. What we are going to do, rather than drawing the graph in general, When you have to solve an equation, you don't have to draw the graph. The drawing of the graph is to show us that we are solving this equation, where we multiply 2x minus 1 by negative 1 negative sign and setting that equal to 5. Basically, we are solving minus 2x plus 1 equal to 5 to find this coordinate here, this intersection point. That means minus 2x is a 4 and x will be a negative 2. To find this intersection, we take the positive version of the graph. That's 2x minus 1, simply set equal to 5 and we'll solve it. X will be 3. So that's how we solve this kind of problems. Okay, let me wipe off my writing here. So that's what we would do if we didn't have to draw the graph. In this question, we've been asked to solve a modulus function set to another equation. You could sketch the graph to understand what's going to happen. The graph of 3x minus 5 in modulus sign has a V shape and its x-intercept will be 5 over 3. So the graph will be reflected in the line x equals to 5 over 3. The other equation is simply 2 minus a half x. This modulus, there is no modulus on the blue line. So you can see clearly it intersects the graph at 2 points. So let's find those 2 points with algebra. The left side of the graph will have the equation negative 3x plus 5 because we multiply the negative sign into that bracket. Then we simply solve the equation as we would. One of the intersection points has x value of 6 over 5. The other intersection point is taking the positive version of this equation here, or rather this equation here, without the absolute sign. So we set them equal to each other and we solve it as you would. Notice both values of x are positive, and that confirms that our answer is correct with the graph. In this question, we are solving an inequality. What does that mean? That means if we plotted the graph of 5x minus 1 inside the modular sign, first of all, we would have an x-intercept of 1/5. So we would have to reflect the graph in the line equals to x equals to 1/5. So reflection in this line means that it would reflect back up from that point, and the intercept would be a positive one. So let's plot that. And the other line is 3x. But looking for is that where the modular sign is above there, or rather the red lines are above or bigger than 3x. That means where the red lines are above the blue line. That is, we are going to find the intersection points and look for this section of the graph, this section of the graph. What values of x will give us those? So that means taking the negative version of the modular sign, multiplying the negative into the bracket, we'll get minus 5x plus 1 equals to 3. When you solve it, you get x equals to 1/8. Now, we'll deal with the inequality sign in a second. Let's solve the positive version of the graph. End up with x equals to 1, x equals to a half. We know that x equals to a half is on the right and x equals to 1/8 is on the left. So any x value that is less than 1/8 will satisfy our inequality because we are looking for a section of the graph where the red line is above the blue line. and we know that where x is bigger than a half will satisfy our inequality. Okay, so let's look at the next example.